angle of elevation, we're in trouble, correct? Okay, angle of elevation. Explain it. What does that mean? Angle of elevation. It's from a horizontal. How about angle? From horizontal up. How about one picture? Here's our horizontal angle of elevation. So we've got an angle of elevation in this problem. What else do you think is a key term? Base. What is a base? What are they talking about base? We have bases of triangles, we have bases of figures, we have bases of 3D figures. What are they talking about when they say base?
The bottom of the ladder.
Bottom of the ladder. Now where is the bottom of the ladder?
On top of the tractor.
Bottom of ladder on the truck, right? Alright. Do you necessarily always put the bottom of your ladder on the truck?
No.
No. Where do you usually put the bottom of your ladders? On the ground. But this is significant. It's on the truck. What does that mean about the bottom of this ladder?
It's higher.
It's higher up. How high? Okay, bottom of ladder on the truck. So ladder, bottom of ladder is 8 feet up. This is something that is easily missed. It'll be interesting to see how you all write the picture. All right. So we have an angle of elevation. Now, what kind of math do you think that's going to trigger in your heads? Of all the stuff we've learned this year, what concepts do you think you're going to have with angle of elevation? Pardon? Congruent? Maybe, but what was your homework involving? You didn't do it? Devin? Corresponding triangles? Alternate interior. All right. So, the angle of elevation and angle of what? Depression are what kind of angles? Are alternate interior angles, and they are right. That is certainly something that may pop up depending on how we draw our triangle. We may need to be okay with angle of elevation to angle of depression, or vice versa. So now that's bringing in our parallel, or unit 1. Okay? What other mathematical concepts do you think an angle of elevation should trigger in your heads? What have you been working with? Sine, cosine, tangent. Do we know what we're working with now? At this moment. All right. What is sine? Opposite over hypotenuse. What is cosine? Adjacent over hypotenuse, and tangent. Opposite. Okay. How many people know this without looking at the notes now? You? Okay, good news is you're going to have that on your reference sheet on the DOC. That's one of the few things they're going to give you. Am I going to make you memorize them? If they are going to give them to you, I'm not going to make you memorize them. If they have not given them to you, would I? All right, so in our brains now, we've brought forth our little folder about angle of elevation, angle of depressions, and their relationship. We've unpacked what it means for the ladder to be on the base, having its base on the truck. We're looking at thinking that, because the angle of elevation, that maybe we're going to be involving trim. All right, you think there's anything else we need here? You think there's anything else in there? Maximum height. Okay, maximum height. What do you think they're going to do with the ladder? Are they going to extend it partway? They're going to extend it out. Right. If you want it to reach as high as possible on the building, then they're going to extend that ladder as far as they can. All right. So our maximum height means that the ladder will be ladder fully extended. How long is that? Right. If it's not fully extended, we could do this problem because we would not know. Fully extended, and that's going to be 100. All right, so when you read a word problem for the first time, this is where you start. You start looking at the words that are in the problem, and you start to ask yourself, okay, what words do I need to think about? What map might those words bring forward as far as what I might need to use? So that you have now at your fingertips, you have your sine, your cosine, your tangent relationships. You have what it means to be an angle of elevation. You understand where the ladder is, and you understand how far the ladder's been extended. That's a huge amount that goes into starting this problem. All right, so the next page is where we're going to start to ask our supporting questions and answers. This is where we're going to take what we have, and we're going to start to ask ourselves questions that will lead to our solution. And Trevor, what did you say in the beginning that we're going to need to do? I'm pretty sure. So what are we going to need to do probably first? Oh, picture. We need to draw a picture. All right? On your test, I have not drawn any pictures. I don't know what the ESC is going to have to use. If they don't draw you a picture, then you need to draw a picture. All right, what should this picture involve? A fire truck. A fire truck. We need a fire truck. So, artist, start drawing. You need a fire truck. I got mine. And where's the ladder going to be on your fire truck? On top. What else are we going to do? Let's go back to the question. Oh, I heard it. Yeah, we need a building. So now you need to draw a building. All right? I got my building. Pardon? Now, what should be the relationship of that fire truck and that building? Well, I mean, on my picture, is this a good picture? Is that a good place for my fire truck to be? Well, look where the base of the building is and look where my wheels are. Are my wheels going to be lower than the base of the building? So if a fire truck came up to my portable, will their wheels be 4 feet down in the ground? No, where will their wheels be? At ground level. Is my fire truck at ground level? Okay, so I need to raise my fire truck, correct? Does that look about ground level? Let me try to draw at ground level. Does that look about ground level? Am I good? Okay, so once you get your building and once you get your fire truck, now what should you do? We're not finished with our diagram. So what's the purpose here? We've got a fire truck. We've got a building. We're talking about a ladder. What's the purpose of the ladder? We want the maximum length, but why would they need the ladder in the building?
Rescue people.
Rescuing people. So is the ladder going to stay where my ladder is?
No.
Where's the ladder going to go? Where?
To the window.
Vertically?
At a 70.
Up and down? No, up to, so we have to draw the ladder so it's what? Slanted. It's going up where? To the building. Alright, so I'm going to make my picture. Now the question, so I just did a little segment there. Can you see my ladder now? Okay. So where should is that a good picture or is that not a good picture?
Sorry.
Where should the horizontal be? Where?
What?
Where should my horizontal be? Should it stay on the ground?
So,
No, where should it be?
where?
On top of what? Okay, so you want the horizontal to be, let me find you want the horizontal to be up here?
So that's one.
Yeah.
Well, okay, but what would be best for our picture? For this situation?
It's on the bottom left.
It's at the bottom of the ladder, all right? How many kids do you think put it totally on the bottom of this truck?
No.
No, it's going to be the bottom of this ladder. All right? So where is my right triangle? Blue, red, and how do I do my other one? Did I think that? The building from here to there, correct? See that horizontal. So let me make this so you can see it. We'll make it bigger. Maybe we'll make it. Okay. You see your triangle. What can you tell me about this distance here? What do we know about the distance from here to here? Right. This distance is 8 feet, but that's not part of my triangle, is it? All right, now that we've drawn a picture, what else do you think? What's the next step? What's the next question you should ask yourself? Okay, so perhaps where do our measurements go? Okay, we've already placed our 8, and that's not part of our triangle. What measurements can we put in?
70 degrees.
Where's 70?
Between the ladder and
In between the ladder and
the horizontal.
the horizontal. So that would be right here is my 70. Can you see that? I'll put it back here. That is 70 right there. Alright, so that's my angle. Angle of elevation, horizontal up. What else do I need? Our right angle, correct. What else do we need? Oh, what is the length of the ladder?
100 feet.
So that's going to be on my blue, right? Have I used up all my measurements?
Yeah.
Okay. So what's maybe the next question we should ask?
What tall is the building?
What's the next angle?
Oh, I heard how tall is the building? What does that tell me? How tall? Now, are we going to be able to answer this question right now?
No.
Everyone's going to do it.
Okay. Are we going to get the full building height right now? No. So I'm going to push that down a little bit. So
What's the next angle?
We've got our angle that we need. We've got our angle. What's the unknown?
Building height?
What is the unknown? Because exactly what we need. First of all, what do you want to let the unknown be? Okay, where should we put X in our picture?
On the building.
On the building. Why on the building?
You don't know it.
Because we don't know it. previous finishes.
What, is this
I'm not
not
sure.
square, buddy? Everybody,
Pardon?
from the top to bottom, or is that?
So the X is gonna be from the horizontal, which is on the bed of the truck, to the top.
Yellow.
We're gonna have to work, we'll talk about how tall the building is in a minute. All right, now that we've got our triangle set up,
Would be X plus two.
I think what I'm gonna do is I'm gonna take this triangle, I'm gonna pull this out so that we can see it a little bit better. We've got 70, we've got X, we've got 100. What do you think you do from here? You label hypotenuse, okay? So where is the, how about label hypotenuse? Where's the hypotenuse?
100.
It is on 100, all right? What do you think you should do next?
Label the adjacent and opposite.
Okay, so label hypotenuse, adjacent, opposite. Okay, so where do those go?
Hypotenuse is 100. Adjacent is 8.
Well,
I'm not-
adjacent's not even part of a triangle.
Yeah, no. Opposite is right.
Opposite is X. So we have hypotenuse, we have opposite. What would the next question, logical question be? What is your trig function? Now, up in the beginning, you have your trig functions written, right? So what is the trig function? All right, I can get that. All right. So if in doubt, you could have gone back to the beginning there, and you could have seen hypotenuse and opposite, and you would have been able to pick out your sine function. So what is the function? It's going to be sine. So now that we know our sine function, that we're using sine, what do you think is the next logical question? What do we do from here?
What's the angle?
Okay. What is the trig function? What is the angle?
7.
And where does it go? How's that? Where does it go? Sine 70. Okay, so we've got now sine 70, all right? Now, what do you think would be the next question?
What's your right ratio?
Okay, what does sine 70 equal? And what does sine 70 equal? X over 100. And if need be, you could have gone back to those key terms, and you can make sure that you put opposite on top, hypotenuse on the bottom. All right, so now once we get to this point, what's your next question? Okay, so we need to solve. What do we need to solve?
100
We're going to multiply this side by 100, we're going to multiply this side by 100. So we're going to end up with 100 sine 70 equals X. And X is 93.97. All right. So let's go back to the question we asked earlier. How tall is the building? Is the building 93.97?
No, we have to add it.
All right, so that goes back. What do we have in this? Look at our terms. Did we address that? Ladder's fully extended base. Bottom of ladder on trucks, the bottom of ladder is 8 feet up. We did 100 times 70. Sorry. No, he would have to go to So you're going to have to do 70. Right?
That's what we
Write that down. But then we're going to, there you go. Okay. All right. So we said that we had to take our 93.97 and do what? Add 8 to it. So the building is going to be 93.97 plus 8, which is?
101.97.
Okay, you think that's a good answer?
Yeah.
I think it's something missing.
Feet.
There you go. 101.97 feet. So the next part is going to be on the next page. And that's where we are to answer the question. So what is the main idea answer? The building is what?
101 feet.
Is 101 point, what do you say? 97 feet tall. So we're in the process of analyzing this question. What do you think common mistakes are when finding the answer?
Using the wrong one.
Using the wrong trig function.
Yeah.
That definitely, wrong trig function. Okay? What else? You mean like wrong unit?
Yeah.
Okay.
Not labeling the right things.
Wrong unit. Poor rounding. Oh, that would be the A number one. Most common mistake is to forget to round. All right. I'm sorry. Forget to add your 8 feet. Thank you. That would be the most common. So forget to add that 8 feet. So what should you always do when you think you have the answer? You go back and you read the what? Problem. And the problem stated, what's the highest above the what? Ground that ladder can reach. And that's when you have to, and I tell the AP kids this all the time, when you have you answered the question, if you stopped at the 97, which I guarantee probably 60 to 70% will, if you decided to click on X, they did not answer the question, right? And I'm telling you, if this were multiple choice, that would be a multiple choice answer. And you get so excited because you see it as one of those things, you immediately grab it. So before you even look at those answers, go back and make sure you've answered the question. All right? So then, how else can we use this? How else can we use this trig in real world uses?
Yeah.
Architects use it? I'm not sure I know that. Did I?
Yeah.
Okay. What are other real world uses? Engineers?
Civil.
Civil? You don't think mechanical might?
All engineers.
Mechanical engineers.
Well, it's just engineering in general.
Engineering in general. When my son's a mechanical engineer, and I asked him, because he had to have Cal 1, Cal 2, Cal 3 different equations, what math he uses the most often? Guess what it was? Geometry and trig all the time. All right, what other real world uses? Surveyors. Surveyors. Their whole thing is based on trig.
What's a survey?
That's someone that comes out and measures your land.
See, we don't know that.
There is a program at UF. UF is the only school in Florida that has a surveyor program. All right, so now we're going to go to your homework. With this, we're going to, if you ask for any of the word problems, we're going to go ahead and try to work on this unpacking of the word problems. So the first 16 questions basically were, what is what? An appraiser, property appraiser?
Sure.
That's someone that figures the value of your land or your property or your building.
Does have to do that.
Do they use trig? They look more at what has been sold, what is for sale, and what has been taken off the market because it was too expensive. All right.
Are you serious?
Brittany, you got a question? Okay. So 19 is a great question for what we're doing here. So what it has said, and maybe I'm going to go to the document so you can see it. It says that we are now meteorologists. So now, we just got another use, didn't we? Who else uses trig? Meteorologist. All right, here's our meteorologist. Our meteorologist measures the angle of elevation of a weather balloon as 41 degrees. A radio signal from the balloon indicates that it is 1,503 meters from his location to the nearest meter. How high above the ground is the balloon? What are some key words? Words. Angle of elevation again. So if we were doing one of these, and on one of you are going to choose one of these word problems on tonight's homework, and you're going to go through this process again. And I will even give you another piece of paper or another packet to do that with, all right, before you leave.
Is that, so that's pretty much like 2 of everything?
No, it's just, you get to choose which one you do. But you're going to have to do what we did in class. You're going to have to write down the key words in the A32 is like 12 problems. You have to do all 12, but one of them you have to break down. All right, so angle of elevation, yes, very important. What else do you think is important? Pardon? Away from his location, all right, from his location. So the radio signal's where? Where's the radio signal coming from? From the balloon. Where's the balloon? In the air. Can you picture that? Okay. So he's standing here, and there's a balloon over there, and what's that balloon doing? It's giving signals. Besides flying, it's giving him signals. Why do they do water balloons, air balloons, weather balloons? They take weather measurements, exactly. To the nearest meter, how high above the ground is the balloon? So what angle of elevation right there should tell you what about the math you need?
It's in the air.
Okay, it's in the air. Angle of, but what math? Sine, cosine, tangent again. So those would be our key words. All right, so now what are you going to do first after that in your supporting questions? Oh, I don't know what it is. So what are you going to do? What are you going to do? Well, wait a minute. You have to ask yourself questions. What questions are you going to ask? Where should you start? Draw a triangle? Draw a picture. And what should be in that picture? A triangle. So what do you think this is going to look like? Maybe I can get it. What do you think this is going to look like?
Where's the guy?
Where's the guy? Here's the guy.
Then there's a balloon.
Then there's a balloon in the air.
Then you gotta have the horizontal line.
Here's my horizontal line.
The angle getting to the balloon.
And what is this?
That's it.
Angle of elevation, okay?
40 degrees.
And so that's 41 degrees.
And then the line.
The diagonal to the balloon.
Okay,
Oh, no, the horizontal is 1,500.
that's the question. Is the 1,503 the hypotenuse or the segment? Let's look. What does it say? A radio signal from what? So where's the signal coming from? Well, something in this balloon is a signal. It's emitting waves, okay? They want to know, they said that the radio signal from the balloon, that is 1,503 meters from his location. Where's his location? That's him. Is he standing here? So it's the hypotenuse. You see how you look at that? What are we looking for? What are we looking for? How high? Is that this horizontal or is it the vertical? The vertical. Okay, what's your next question? What trig function? But in order to find that trig function, what do you need to know? This is opposite. This is hypotenuse. So to answer your trig question, what do? Sine 41 x over 1,503. If you did not know how to set up your proportion, you could go back to your key concepts, your key terms, and look at that ratio. So then what should your next question be? How do I solve it? Okay, we're going to multiply each side, and then what? X equals, and then you solve whatever that happens to be. And then what's the next question? Did you answer their question? Okay, and it also said, did anybody do this, by the way? No, that calculator? Will someone do this in the calculator, Becky? 986. Okay, what did they ask us to round to? The nearest meter. What would this round to then? 986, all right? And the question is, did we, and that's 986, what unit? Meters. Did we answer the question? Yes, we did, because it's from the ground. It wasn't that funky stuff with the fire truck that started above the ground. Be aware, because some of those problems will start above the ground. Are you clear on the expectation of homework? You've got this worksheet to do. I think there's 12 problems or less. One of those you're going to write up on a packet I'm going to give you like we did today. I'm going to count that as a quiz grade. That one question that you write up. Yes, for homework. No, we did this one together. Yes. What other questions do you have? Yes. 23. All right. Here's another great question. So here we go. Let's unpack the question. The world's tallest unsupported flagpole is 282 feet tall. Steel pole in Surrey, British Columbia. The shortest shadow cast by the pole during the year is 137 feet long. To the nearest degree, what is the angle of elevation of the sun when casting the flagpole's shortest shadow? What key terms are in this problem? Okay, that is a number, and what does that relate to?
Oh, okay.
So you'd say 280 feet tall is height of what? Flagpole from what? The ground. Why is that important, from the ground? Because the fire truck we had was not from the ground. Where was it? From the truck, okay? What else is important in here?
Angle of elevation.
Angle of elevation, and you're gonna say angle of elevation is the angle from the horizontal up. And so you also can make a notation in your key terms that this is what we're supposed to find. What else is important? Okay, so shadow. Now this may seem silly, but where's a shadow? On the ground. I had kids 2 years older than you not know this. Okay? They were making it the hypotenuse in the air. The shadow's where? On the ground. And so how long is that shadow? 137 feet long. Do you think you can draw this picture now?
Yeah.
So what should I draw?
It's fine.
Okay, I draw a triangle. What does this represent?
The flagpole.
The flagpole. So let's put a flag on it, all right?
The bottom,
The shadow.
that's
Okay, that's the shadow, so we'll make it darker. That's our shadow. And how long is that? 137.
how long the flag.
How old? 282. What are we looking for?
Oh, wait,
You're looking for the angle of elevation.
What are we looking for? So that's a question that was important to ask. What are we looking for? Okay, where should that be?
Bottom left.
Bottom left, because it's from the horizontal up. What's the next question?
What's the trig function?
opposite of
Okay, and before we can answer the trig function, what do we need to know?
what tangent.
Before we even know how it kind, what do we need to know?
What's opposite?
What's opposite? What's opposite?
Tangent.
Okay? What?
One place over the
Okay, now with that information, we know that it's tangent, and you should have put sine, cosine, tangent on that front part. Tangent of what? All right? How do we set it up? Over.
137.
All right.
And you gotta use the inverse.
So this is one of those different ones. We don't know the angle. We have to extract the angle from tangent, and the only way we can do that is to
Tan inverse.
tan inverse the left. Then we must do what to the right?
Tan inverse.
Tan inverse the right. All right, and the tan inverse cancels, and what do we get? 64.09, what are my units? Okay, so let's go back.
degrees, we're finding an angle.
We're finding an angle. So that should have been probably one of our questions. What should our unit be?
And it's saying relative to the nearest.
And it does it say round? Round to the what? Nearest degree. So how do we round this to the nearest degree?
64 degrees.
So that's going to be 64 degrees. Now, should always be our last question. Did we answer the question? What was the question? Angle of elevation. Did we get that? Yes. So what's the expectation tonight? I want to make sure you all are aware. You're going to do the worksheet, and one problem from that worksheet you will do what? You are going to do, no, you're going to keep that. You're going to keep that for reference tonight. So you are going to do, of one of those problems, you're going to do one of those problems where? On here, unpacking.
Are you kidding
I'm going to let you pick your choice. So you all might have different problems.
Any problem you want?
Any problem you want. So how many should be on your notebook, please? 11. And where's the 12th one? On this. On this. Okay, I have a front page, but not that.
You want something?
Okay.
Wait, yeah, give her your homework. Which Friday do you want the homework?
Yes, I'm going to need the homework. All right, I'm going to have to. 1, 2, 3, 4. How many more do I need? You have enough? I need 4 more.
Got it? Oh my god, I do that.
Pardon? It's stapled. It was stapled. It would have messed up the print. So